NASA is keeping the James Webb Space Telescope away from Mercury, and the reason might be more shocking than you think. This powerful telescope can see deep into space, capturing hidden details of distant planets and galaxies. Strangely, NASA has no plans to use it on Mercury, a planet that should be full of scientific wonders. What could be there that makes them avoid it completely? Tune in, because what's lurking on Mercury is so terrifying, NASA shut down all their operations there. Mercury is no ordinary rock circling the sun. It's a scorched world where temperatures swing from unbelievably hot to freezing cold. That's enough of a reason to be curious, right? But when scientists talk about Webb, they focus on its giant sunshield, designed to keep the telescope cool while blocking out the sun. Officially, NASA says that pointing Webb too close to the sun, where Mercury sits, could fry its sensitive instruments. Sure, that makes sense, but wouldn't they have accounted for that in their designs? It's almost as if they built this massive, high-tech observatory, but conveniently left out a way to study one of the most extreme planets in our system. Before we delve into this, it's clear that NASA's silence on Mercury is more than just a technical issue, and what they might be hiding could be far more shocking than we expect. Let's not forget that Mercury has always been full of surprises. Strange magnetic fields, unexpected ice in its shadowed craters, and even strange structures that don't seem natural. When NASA's Messenger probe orbited Mercury, it picked up some bizarre data, patterns in the landscape that didn't match the usual planetary geology. Some of these formations looked suspiciously like artificial structures, almost as if something was built there long ago. And yet, instead of following up with Webb, NASA moves its focus elsewhere. Convenient, isn't it? And then there's the question of infrared detection. Webb is designed to capture heat signals, which means it could see any energy signatures coming from Mercury. If there were any strange heat emissions, say from underground activity or something technological hidden beneath the surface, Webb would be able to spot it. But that can only happen if NASA actually looks, and from the way things are going, it seems they don't want to. It's also worth noting that Webb's position in space gives it an incredible advantage. Placed over 1 million miles away from Earth at the L2 Lagrange point, it has a stable, clear view of the universe without interference. But that also means NASA controls what it looks at. Unlike older telescopes where data was more freely available, Webb's observations are carefully managed. If there were any unusual findings on Mercury, who would even know? The public only sees what NASA decides to release. This whole situation raises a bigger question. What exactly is on Mercury that NASA doesn't want Webb to find? Maybe they already know something. Could there be ancient ruins, hidden structures, or something else entirely? We already know that space agencies have a history of keeping discoveries under wraps. After all, if the world suddenly found out that another civilization once existed in our own solar system, it would change everything. People might start questioning history, science, and the true purpose of space exploration. There's also the possibility of active phenomena on Mercury. Some researchers have theorized that certain celestial bodies, including the Moon and Mars, might have hidden activity underground. If there's any kind of artificial energy source, an ancient machine, or even something still functioning beneath Mercury's surface, Webb would be able to detect it. But only if it's actually allowed to take a look. Think about it. Webb has already revealed so much about distant galaxies and exoplanets, yet the closest planets to us remain a question. Mars, Venus, and even the Moon have been under study for decades, but Mercury, it's mostly ignored except for the occasional passing probe. And now, with our most advanced telescope ever, they claim it's too risky to point it toward Mercury. It's almost laughable. This secrecy is nothing new. Space agencies have been accused of hiding information for years. There are countless cases where NASA's images have shown strange anomalies, objects that don't belong, signals that don't make sense. But instead of investigating further, these findings are brushed aside, labeled as a natural or coincidental. It's a pattern we've seen before, and Mercury could be the latest piece of the problem. If there really is something hidden on Mercury, who benefits from keeping it quiet? The truth is, space exploration isn't just about science. There are government contracts, military interests, and power struggles behind the scenes. Information is controlled, and what the public sees is carefully filtered. If Webb were to find something groundbreaking, something that rewrites what we think we know, it might never be made public. And yet some pieces of the problem slip through. Strange readings from past missions, unexplained formations, and whispers of anomalies all point to something more. Even without Webb, we know that Mercury is far more than just a dead rock in space. It has a magnetic field that shouldn't exist, ice in places that should be boiling hot, and a surface that has been reshaped in ways that defy explanation. So the big question remains, why won't NASA let Webb take a closer look? If the telescope is as powerful as they say, it should be able to confirm or deny the strange theories surrounding Mercury. But instead of investigating, they dismiss the idea entirely. That alone should make us wonder. If Mercury has something NASA won't talk about, then maybe Webb's whole story is just as strange. Imagine pouring billions into a telescope that took decades to make, only to have it delayed over and over again. That's exactly what happened with the James Webb Space Telescope, a project so ambitious it seemed doomed from the start. But despite the endless setbacks, mind-boggling costs, and design headaches, this telescope finally made it into space. Now, scientists are betting big that it will change everything we know about the universe. The real question is, was it worth it? Back in the early 1990s, before Hubble even had a chance to prove itself, scientists were already dreaming of the next big thing. They wanted a telescope that could peer into deep space using infrared technology, revealing things no one had ever seen. They wanted to look back in time, literally, to see the first galaxies forming after the Big Bang. Sounds great, right? But getting from an idea to a working telescope was anything but easy. By 1996, the plans started coming together under the name Next Generation Space Telescope. It was supposed to have a 26-feet mirror, a massive improvement over Hubble's tiny 7.8-feet mirror. That alone was enough to raise eyebrows. How were they going to launch something that big? Well, they had to make it fold up like a piece of origami and hope it would unfold correctly in space. Not exactly reassuring. The infrared technology meant this telescope needed to be kept incredibly cold, shielded from the sun's heat. That led to another major design challenge, a sun shield the size of a tennis court. Think about it, a delicate, multi-layered structure that had to survive the violent launch and then deploy perfectly in space. If anything went wrong, billions of dollars would be wasted in an instant. In 2002, the project got a new name, the James Webb Space Telescope, named after a former NASA administrator. This was supposed to be a sign that the project was important and historic. But instead of inspiring confidence, it became a running joke. Budget overruns, endless technical problems, and constant delays turned it into one of NASA's most criticized projects. By 2004, they finally started building the thing, but every step forward seemed to come with 2 steps back. Engineers had to make sure the 18 mirror segments, each made of beryllium and coated in gold, could survive the freezing temperatures of space. Every test seemed to uncover new problems, forcing them to go back to the drawing board. This wasn't just a case of fine-tuning, it was full-scale redesigns, each adding more time and more money to the project. By 2011, all the mirror segments were finished, but that didn't mean the telescope was anywhere near ready. There were still instruments to integrate, alignment tests to run, and countless simulations to make sure it could handle the brutal conditions of space, and of course more delays. The original launch date of 2007 kept getting pushed back. 2010, then 2015, then 2018. At some point, people stopped believing it would ever launch. It wasn't just technical problems. The budget spiraled out of control, going from a few $1 billion to over $10 billion. Politicians started questioning if it was worth it. Scientists defended the project, saying it would revolutionize space exploration, but it was hard to ignore how much money was being poured into it with no results to show. In 2018, after years of waiting, all the telescope's parts were finally delivered to Northrop Grumman's facility for final assembly. This was supposed to be the home stretch, but surprise, more delays. Integrating all the components, including the ultra-sensitive instruments, took longer than expected. Then came the final rounds of testing, where they simulated the intense vibrations and noise of a rocket launch. If anything failed at this stage, they'd have to start over. Finally, the launch was scheduled for December 25th, 2021. Yes, Christmas Day. The European Space Agency provided the rocket, an Ariane 5, which had a strong track record of reliability. This was it, the moment of truth. If anything went wrong, there was no backup plan. Amazingly, the launch went off without a hitch, but that was just the beginning. Unlike Hubble, which needed a simple lens adjustment after launch, Webb had to assemble itself in space. The sun shield had to unfold, the mirrors had to align, and every instrument had to start working. For weeks, NASA held its breath as each stage was completed one step at a time. By mid-2022, Webb started sending back its first images. The results? Stunning. Galaxies from the dawn of time, exoplanets in detail never seen before, and cosmic structures revealing the universe in ways that had only been imagined. The telescope was living up to the hype, at least for now, but the bigger question remains. Was it all worth it? $10 billion and decades of work for a telescope that might last 20 years. Sure, the discoveries are amazing, but could that money have been spent better elsewhere? Some argue that Earth-based problems should take priority. Others say the knowledge we gain from Webb could change our understanding of life itself. After years of delays and problems, Webb finally reached space, but what it is finding is far more surprising than anyone imagined. The James Webb Space Telescope has been shaking up everything we thought we knew about space. Scientists thought they had the universe figured out, but this telescope is proving them wrong, over and over again. It has spotted galaxies from just 300 million years after the Big Bang, an event that supposedly happened over 13 billion years ago. That light traveled all this way, carrying things from a time when the universe was barely getting started. And then there's JD's GS Z14 Cero, the furthest galaxy we've ever seen. It shouldn't even exist based on what we thought we knew, but there it is. Bigger, brighter, and way more developed than it should be. How is that possible? Well, it's making scientists rethink everything about how galaxies formed in the early universe. Then, in May 2024, JWST picked up something even wilder, the most distant black hole merger ever seen. This happened in a galaxy system called ZS7, about 740 million years after the Big Bang. It seems black holes in the early universe were growing way faster than anyone expected. Scientists used to think black holes slowly swallowed matter over time, but now, this discovery hints that they bulked up quickly and early. Could it mean the rules of the universe are completely different from what we thought? And if that wasn't enough, in June 2023, JWST found organic molecules in a galaxy 12 billion light-years away. That's right, organic molecules, the kind needed to make life. This means the building blocks of life existed long before Earth was even a thought. We have no idea what that actually means yet, but it raises a huge question. Was life out there way before us? JWST isn't just finding galaxies and black holes, it's also finding objects that defy everything scientists expected. Take the Jupiter Mass Binary Objects, or JUMBOs for example. These are free-floating objects in the Orion Nebula that are paired up, like planets with no stars to orbit. Each one is between 0.7 and 13 times the mass of Jupiter, and they're sitting at crazy distances from each other, anywhere from 28 to almost 400 times the Earth-Sun distance. This discovery is a huge problem for current theories on how planets and stars form. If planets are supposed to form around stars, why are these just floating around in space? Scientists don't have an answer yet, but one thing is clear: something isn't adding up. And then there are the red monster galaxies. These gigantic star-filled galaxies shouldn't exist in the early universe, but JWST keeps finding them. According to what we thought we knew, early galaxies should have been slow, messy, and just getting started. Instead, these things were churning out stars at insane rates, turning almost 50% of their material into stars. That's 500 times faster than what the Milky Way is doing now. How did they manage that? Some think supermassive black holes might be behind it, pulling in gas and feeding star formation. Others wonder if cosmic filaments funneled matter into these galaxies way faster than we realized. Either way, the rules of galaxy formation may be completely different than we assumed. Webb is not just showing new things about space, it is proving that much of what scientists believed was wrong. JWST isn't just looking deep into the past, it's also giving us fresh looks at planets closer to home. Take Jupiter, for example. It captured detailed images of the gas giant's swirling storms, delicate rings, and chaotic moons. Jupiter has always been strange, but now we're getting a clearer picture of what's really going on in its atmosphere. These new images give scientists a better understanding of how Jupiter formed, how its weather patterns work, and what its role in the solar system might actually be. And speaking of planets, JWST is helping in the search for alien worlds too. It found water in the atmosphere of WASP 96b, a gas giant over 1,100 light-years away. Finding water is a big deal because it could mean some planets out there have the right conditions for life. Of course, WASP 96b is a gas giant, so it's not exactly the kind of planet we could live on. But the fact that JWST can detect water so far away is a huge step forward in finding planets that could actually support life. If we can spot water here, who knows what else is waiting to be discovered? The telescope is also shedding light on how stars live and die. Its images of the Southern Ring Nebula, a glowing cloud of gas from a dying star 2,500 light-years away, reveal how stars spread elements into space when they die. Those heavy elements eventually form new stars, planets, and even life. Without dying stars, there wouldn't be enough complex material in the universe for Earth or us to exist. JWST is showing us this process in a way we've never seen before, filling in the gaps about where everything, including us, comes from. Then there's Stephan's Quintet, a stunning view of 5 galaxies locked in a cosmic dance. 4 of them are actually close together, about 290 million light-years away, while the 5th one just happens to be in the background. These galaxies are crashing into each other, mixing up gas and dust, and sparking the birth of new stars. This kind of galactic chaos isn't rare, but JWST's detailed view is helping scientists understand exactly how galaxies grow and evolve over time. It's showing us how the past shaped the universe we see today. The big picture: JWST is tearing down old ideas and forcing us to rethink everything. The universe is turning out to be far more chaotic, unpredictable, and weird than we ever imagined. Galaxies shouldn't be this big so early. Black holes shouldn't have grown this fast. And planets shouldn't just be floating around with no stars to call home. Scientists are scrambling to keep up, rewriting theories as JWST continues to deliver one shocking discovery after another. The telescope was supposed to confirm what we already thought we knew, but instead it's raising even bigger questions. How did the first galaxies form so quickly? Why were black holes already massive in the early universe? And the biggest question of all, if the building blocks of life were floating around billions of years ago, could something, somewhere have started long before Earth ever existed? Or is there something hidden on the planet they don't want us to see? Tell us what you think and remember to like and subscribe for more.